Alright, I want to do a video here regarding just some IP basics for PBX text, try to relate a lot of the IP terminology over to the PBX side of things as well, since a lot of it is very similar on how they're configured. So we'll get into that. Alright, so IP addresses are things that I'm sure most of you are familiar with, needing to get the following of an IP address, and then we'll go into each of those. So you have the IP address itself, either a private or a public, dynamic or a static IP address. You have the subnet mask that you want to get, as well as the default gateway, and then usually a primary and an alternate DNS. So, and then we'll go and we'll get into each of the parts of these, what they're for, and again, any kind of equivalents to the PBX world. Alright, so what is an IP address? IP address is a number assigned to a computer or other device that is communicating on an IP network. Every device needs an IP address to communicate on the internet. It is equivalent to a phone number or an extension number in a PBX. With IP version 4, it's going to be a set of 4 numbers, 0 through 255, that's separated by a period. So IP version 4 will look like 192.168.1.1. There is IP version 6, which looks like this. We do not run into this very much yet, so I'm not going to go into it, but just so you're aware, it is there. The reason for it really is just that they have run out of IP version 4 addresses, so they created IP version 6, which has a lot more numbers, as you can see. But again, we're not going to go into it, since we're not running that really on any of our networks for the phone systems, and we don't run into it very frequently, if at all yet, on the public side even. Alright, so the next portion, other than the IP address that you need, the second thing is the subnet mask. Now, IP addresses are like phone numbers in that they're made up of different sections. So with a phone number, you have your area code, your prefix, and your block. IP addresses are made up of a network portion and a host portion. But unlike a phone number, where this is always going to be the area code, this is always going to be the prefix, and this is always going to be the block, IP addresses, the network versus the host portion, is dynamic. It's changeable, it's adjustable, and that is all defined by the subnet mask. So for example, the 255.255.255.0, that defines in this address that these first 3 numbers are the network portion of this IP address. And then this last part is the host portion, which is what you would assign basically to the devices themselves, be it a computer, phone, whatever. Now, if this subnet mask were to be 255.255.0.0, that would mean only these first 2 numbers are the network portion, and the second 2 IPs are the host portions. So the subnet mask defines what the scope of the subnet or LAN is and what part of that can be used for hosts. So again, for example, looking back at this, if you have a device at 192.168.1.1 and it has this as a subnet, that means it's only going to communicate to devices that have these first 3 digits as the same. So if there's a device that has a 192.168.1.2, it'll be able to communicate with it. If there's an IP address that has a 192.168.2.2, it would not be able to communicate with it, since it would be on a different network portion. Now, if they had a 255.255.0.0, and again you had a device 192.168.1.1, and you had another device 192.168.2.1, and they were connected together, or 2.2, excuse me, they would be able to communicate with each other if they had this subnet, because they would have the same host range here. So again, on this subnet mask, it would be just these 2 numbers. That would be the network portion, and then these 2 would be the hosts. Now you can also get into, subnet mask can get kind of deep, where you can get additional, it's called multi-link subnet masking, where you can kind of split these numbers in half, more or less, for the network portion versus the host portion. But we won't get into that, but just know that the subnet mask defines what portion of the IP address is the network portion and which is the host portion. All right, so what is a private IP address? So kind of like we got into before here, there are only so many IP version 4 addresses available. So the governing body who manages the IP addresses decided to set aside multiple blocks of IP addresses that can only be used on internal networks. It will not be able to go across the internet. I'm sure you're pretty familiar with all these or have seen these, but these address blocks are 192.168.0.0 through 192.168.255.255. 172.16.0.0 through 172.31.255.255, and then 10.0.0.0 through 10.255.255.255. The closest thing you could really relate to it would be, special numbers like toll-free numbers 855, 844. That the telephone system. Governing body there has defined those as toll-free numbers, where in this case the people who govern IP addresses have defined these as basically special IP addresses that can only be used on internal networks. So that basically the private IP addresses are equivalent to an extension number behind a PBX, where you can use that extension number to call internal to the phone system, but you cannot dial that extension directly from another system. So while 101 can dial 102 on this phone system and reach that, a phone number or a phone out here in the public network would not be able to just dial 102 and receive and get to extension 102. Goes the same thing for IP addresses. So on this network here, the computer that's at 192.168.1.101 would be able to communicate with this computer at 1.102 just by using that 192.168.1.102 address. But a computer out here would not be able to just type in or try to get to 192.168.1.102 and get to this, because there's probably multiple or thousands of devices that have this same IP address, just like there's probably thousands of phones that have extension 101 or 102. So these addresses can only be used locally. Same thing with the phone numbers. Extensions can only be used local to the phone system or local to the network. So what's a public IP address? Public IP addresses are other IP addresses that are not defined as private IPs or blocked off for any other use by that governing body. So pretty much any address 1.0.0.0 through 255, anything in that range that's not one of those private IP addresses, and there's also some other ones that are reserved for other things, but basically all the other ones are available as public IP addresses. These are blocked out. They're assigned to different regions like North America, South America, Asia, etc. And then from those they're given to the various ISPs, AT&T, Verizon, Comcast, whomever, who then takes those IP addresses and assigns them out to their customers. So public IP addresses are unique to every device that has one. If two devices have the same public IP address, it will cause a conflict. Public IP addresses are able to traverse the internet worldwide. This is basically equivalent to a public phone number that can be dialed from anywhere in the US, but it applies worldwide to as everyone uses the same format, the 192.168.1.x, instead of having a different dialing format like we use for worldwide phone numbers. So you can get to a public IP address from anywhere else on the internet that has internet access. You're able to get to those addresses worldwide. So another portion is, what is a static IP address? A static IP address is an address that is manually configured on a device. The IP address will not change without someone logging into that device and changing it manually. A static IP could be either a public or a private IP address, depending on requirements and where that device is connected. Typically, network equipment that is providing a service on the network will have a static IP address, as you do not want that to change. So usually things like your default gateway, your DNS servers, or anything that's providing some sort of service, an FTP server, or a phone system would have a static IP address, since you wouldn't want that to change. Usually business type internet circuits will require that you statically configure the IP addresses on the public side of that network. So any of the equipment that you're plugging directly into AT&T or whoever would usually need to be statically or manually configured with the IP information that AT&T or Verizon gives you with that. So equivalent to basically a phone number, extension number, where those are going to be manually configured. They're not just handed out randomly. So what is a dynamic IP address? Dynamic IP address is an address that's assigned to a device automatically from another device, which is going to be your DHCP server, on the network. The IP address may change each time a device is connected to a network, but will usually have a lease time set on it. It allows the DHCP server to ensure devices are not duplicated so that they're not handing out the same address to multiple devices on that network. Allows much easier management for complex networks, so you don't have to go in and manually configure every single device on that network. On smaller networks, usually the router, the gateway, will also be the device that's acting as a DHCP server and handing out those addresses. But this could be another device like a PBX or a standalone DHCP server. So, for example, typically on our networks, our router will not have, for our PBX networks, the router will not have DHCP enabled, and DHCP will actually be handled by the phone system itself. You do not want to have multiple DHCP servers running on the same network. That can cause conflicts, IP conflicts, and can cause just general confusion, more or less. So typically you would only have a single DHCP server on the network. So again, for example, in our phone system networks, we're typically disabling the DHCP server that could be enabled on the router, and we only have DHCP enabled on the phone system. Usually business internet circuits will not have DHCP server running on them, so you can't just go and plug your computer into a fiber circuit and have it get an IP address from Verizon or CenturyLink or whoever. Most of those are going to be, you're going to need to configure a static address on your device. Where most home connections do have a DHCP running, so like if you have a DSL modem at home, you can usually just plug straight into that and it will hand you an address that you can use. That address may be a public address, and it may be a private address, depending on how the ISP has configured their equipment. There's not really an equivalent in the phone world, as far as I know, anyways, to a dynamic IP address. But it would basically be like if you got a different phone number each time you plugged your phone in. So if you unplugged your phone, plug it back in, you'd have a different phone number. Unplug it, plug it back in, get a different phone number. For phone system stuff, that wouldn't really work. But for computers and IP networks, it works quite well. All right. The next thing that you typically need after you have the IP address and the subnet mask is going to be the default gateway IP address. The gateway IP address is equivalent to the dial 9 in a phone system. It's the IP address of the device that has a way out of the local network. The device will be capable of routing IP addresses and has its own route table, which is equivalent to ARS in a phone system. So without a gateway IP address, the device will be able to communicate to a device on its local network, but will not be able to communicate with anything outside of that local network. So for some devices, you don't have to have a default gateway. So for like an IP phone on most of our My Telephone System networks, it doesn't have to have a default gateway, or doesn't have to have a valid default gateway, as that phone is only communicating with the phone system itself, which is on its local network, or the other IP phones on that same local network. If that IP phone itself needed to get internet access for some reason, then it would need a default gateway. The default gateway is typically going to be the first usable IP address in a subnet, but it does not have to be. It's just like you normally use 9 to dial out of a phone system, but you don't have to. It's all dependent on who programs it, who sets it up, and what they want. So like on a phone system, you could have dial 8 to dial out. You could have, you could set whatever you want in a phone system to have as your dial out digit or digits if you wanted to do that. Same thing with the default gateway, is that it doesn't have to be the first IP address available in that subnet, but typically it is. It's just kind of the default, just like 9 is usually going to be the default for dialing out of a phone system. Most networks will only have a single device on the subnet that will be a default gateway, but not always. It doesn't have to be. You could have multiple devices that could be acting as a default gateway. That'd be pretty abnormal, not typical. And then for your devices, they're only going to have a spot to enter in one default gateway. So your devices won't be able to be configured with multiple default gateways, but you could have basically multiple routers on the same network that would be could be a default gateway. But again, that would be pretty abnormal. All right, the next thing after the IP address, subnet, and gateway that you typically are going to need to configure is DNS. The phone book is the perfect equivalent to DNS in the phone world. It allows a name to be associated with an IP address, just like the phone book allows you to associate a name with a telephone number. Everything talks to everything else on the internet by using an IP address, but these are difficult to remember. DNS allows you to use a name, such as google.com, which your computer then reaches out to the DNS server to find the IP address for the name you entered. The DNS server can be a server that's local to the network or could be located out on the internet. So when you try to go to google.com, it reaches out to your DNS server and gets the IP address for google.com. So in this example, I did a lookup for google.com. Our DNS server replied with, "This is the IP address for google.com." And so now my computer knew, okay, the IP address for google.com is here, and can send those requests out to there for Google. DNS servers, again, located on the local network or not. A lot of the times you're going to probably be using Google DNS, which is obviously located out on the internet. Or you could be using the 192.168.1.1, which would be on your local network there. Let's see. Usually DNS will be handed out automatically along with the IP, subnet, and gateway information from the DHCP server. Typically, each device will have 2 entries for DNS, a primary and a backup in case the primary server does not respond. You don't have to have 2 DNS servers. You could just have one. This is just a redundancy deal. Devices do not need DNS to do basic communication on the internet. Devices only need DNS if they're using host names. So if you have a device that is only communicating via IP addresses, you don't need DNS. So for example, for like the Mitel 200s, if they are just doing FTP backups, you configure the FTP server as an IP address in there. You don't have to have DNS configured on the phone system for it to be able to communicate out to the internet and do that FTP backup to an external FTP server. You don't have to have DNS configured to be able to get into the phone system remotely. The only time you need DNS is if that device itself is using a host name to look up an IP address or look up a server name or something like that. Common DNS entries are the default gateway or router on a small network, like the 192.168.1.1. Could be the ISP's DNS server, so Verizon, AT&T, or whomever's providing that circuit will typically provide DNS server IP addresses as well. Or they could be just using a public DNS server like Google operates 8.8.8.8 and 8.8.4.4. Most corporate networks will have a standalone DNS server or ones that are located on server IPs that are not the default gateway. So if your default gateway is 192.168.1.1, it could be another server device running on that same local network that would be 192.168.1.5. It could be. So most corporate networks wouldn't have the DNS server also running on the default gateway. But that's all configuration and setup. on how that's done. All right, so quick note, just getting into that small routers, is that most small home type routers that are in use are not just routers, but they're a combination device that puts the following all into one box. It's a router, which allows you to connect multiple LANs, different LANs together. It also usually has a network switch built into it, so it'll have the 4 ports that act as a network switch. It'll have a DHCP server, so it'll hand out IP addresses for anything that's requesting it. It has a DNS server that allows those devices to ask that router, hey, where's google.com? And then a lot of them have a wireless access point built in as well that have the antennas, and you can configure that for wireless. All right, so kind of putting all of this stuff together. When you connect, this is basically your basic network. So you have your computer, you plug it into your small router, and that small router is connected to the internet. When you initially plug this computer in, it will not have an IP address usually. You're not going to statically configure one. It's going to be set to dynamic or to obtain that IP address automatically. So when you plug it in, your computer or device is going to reach out to the network and say, hey, I need an IP address. Most of the time, your small router is going to be what's handing out IP addresses on the network, or it could be a phone system. But it's going to go in and it's going to say, hey, you can use 192.168.1.1.1. The subnet mask is 255.255.255.0, and your default gateway is 192.168.1.1. Your DNS is 8.8.8.8 and 8.8.4.4. So the router, the DHCP server, will give that information to the computer. Once the computer has that information, and let's say you type in google.com into your web browser, your computer is going to say, well, I need the IP address for google.com. I don't know what that is, so I need to look that up. Okay, my DNS server, which is basically my phone book, to look up those addresses for a host name for google.com is 8.8.8.8. Now, my IP address is 192.168.1.101, and that's all I know that my network here, because my subnet mask is 255.255.255.0. My network, my local network, does not have 8.8.8.8 in it. So I needed to send out a request, but I don't know where that address is. So what it does, since it doesn't know where that 8.8.8 address is, it's going to send it out to its default gateway, which is going to be the 192.168.1.1. And it's going to say, hey, I need to get to 8.8.8.8 because I want to know what google.com, what the IP address is for that. The router will pick that up and says, okay, I know where 8.8.8.8 is, so I will send that request for you. So it sends it out to the internet and says, hey, 8.8.8.8, I need to know where google.com is. And the internet, 8.8.8, replies with, hey, Google is at 12.12.12.12, or whatever IP address it is. And the router says thank you, and sends that back to the computer and says, okay, Google is at 12.12.12.12. Computer says thanks. And then it says, all right, I want to send out that request to google.com. So now I need to go to, I know where google.com is now. It's at 12.12.12.12. Again, that's not on my local network, so I need to send that back out to the default gateway. And it sends that request for 12.12.12 out. Router sends it out to the internet. Internet comes back with google.com for that computer using that 12.12.12.12 address. So that's the basic network flow of how IP information flows through using the IP address, the subnet mask, the gateway, the default gateway to be able to get out to the internet, DNS to be able to look up those host names like google.com, abc.com, wherever you're going. Yeah, that's pretty much it. So hopefully that helps, at least kind of gives a basic understanding of some of the IP information, and hopefully answers some questions.